Today I'm going to be showing you how to solve ideal gas problems. So here we have our first problem. 6.2 liters of a gas are contained at 3.0 atm and 37 degrees Celsius. How many moles of this gas are present? So we need to fill in our pressure, our volume, our number of moles, our gas constant, and our temperature. So we can see right here we have our pressure 3.0 atm. So we can write that down, 3.0 atm. Our volume is going to be 6.2 liters. Our number of moles is what we're looking for. So we're looking for how many moles. So that's our x, that's our variable. Our gas constant, which we know, is 0.0821. And then, 0.0821 liters atm per mole Kelvin. And then our temperature. Right now we have it at 37 degrees Celsius, but we can't have it at Celsius. We need to convert it to Kelvin. So the way we do that is we'll write it right down here. We have our 37 degrees Celsius, and we need to add that to 273 in order to convert it to Kelvin. So we add those together and we get 310 degrees Kelvin. So that's what we write right there. So now all you have to do is plug it into the equation and you'll be able to solve for the correct answer. So here we go. We'll have our PIV NERT, which is a great way to remember it. So we plug it in here. So we have 3 times 6.2 equals x, which is what we're looking for the number of moles. Then times 0.0821, which is our gas constant. And then times 310. So if you work this all out, you have 18.6 equals, alright, so pull out your calculator and solve that out. And when you plug it in, 0.0821 times 310 is 25.451. And then we bring down the x, so right there. And now what you want to do is you want to divide 18.6 by 25.451. So we plug that in the calculator. 18.6 divided by 25.451. And now we have x equals 0.73. So that's 0.73 moles because that's what we're looking for. And here we have our answer. Alright, now here's our next problem. At what temperature will 0.654 moles of neon gas occupy 12.3 liters at 1.95 atm? So the first thing we're going to do is we're going to say what our variables are. So we immediately know that we're looking for temperature. So we can write our x right there. R, we know that immediately, 0.0821, because that's our gas constant. N is our number of moles. If you look right here, we have 0.654 moles. So we can write that, 0.654 moles. Then our volume is 12.3 liters. And our pressure is 1.95 atm. So now we're going to plug this into our equation. So we have PIV NERT. Boom. I love that acronym. I know I said that before, but I'm going to say it again. So we have 1.95 times 12.3 equals 0.654 times 0.0821 times x, because t, x, you know what I'm saying. Alright, so now if we're gonna do the math. So 1.95 times 12.3, that gives us 23.985. Now I love right now all the sig figs just because it helps get a more exact answer. So now we're going to do this again right here. 0.654 times 0.0821, and you do that and you get 0.05369. You go back to 4 and you'll get a decent answer, x. Alright, so because you bring the x down. So now what you're going to do is you're going to divide 23 by 0.05369. So you do 23.985 divided by 0.05369. And you get x equals 446.73. It's a huge number. It's in kelvins. You box your answer And bam! You got it right. Thanks for watching.